What is Fantom? FTM. With its Lachesis consensus process, the smart contract platform Fantom seeks to address the scalability issues that other blockchains face. The Fantom network's native token is called FTM. On Fantom, it is employed for staking, voting, sending payments, and paying transaction fees. Because of its emphasis on scalability, the Fantom network has grown in popularity. It enables developers to create dApps and manage smart contracts while also providing a native token, FTM, for staking and making payments. Fantom is a blockchain platform that supports smart contracts and aims to address the trade-offs between scalability, security, and decentralization that many blockchains must make. The blockchain trilemma refers to these three components, which means that focusing on two of them frequently means sacrificing the other. With its cutting-edge proof-of-stake, POS, consensus method, Lachesis, Fantom seeks to overcome these trade-offs and improve on all three. FTM is the Fantom network's native token. It is employed for betting, voting on significant choices, sending money, and defraying transaction costs. How does Fantom work? The Fantom network was built around four core principles. Modularity. Fantom's modular architecture allows for a high degree of customization. Decentralized apps, dApps, built on Ethereum can be readily ported to the Fantom mainnet, which is run by Opera, the open-source blockchain that Fantom built to power its network. Scalability. Because Fantom applications are independent of one another, the performance and stability of one application are not impacted by network traffic at large. Open source. The Fantom protocol's underlying code, which has been posted on GitHub, is available for anyone to run a node and modify. Security. The Lachesis consensus process, which according to the Fantom developers is quicker, more secure, and more scalable than the classical and Nakamoto consensus systems, secures the Fantom platform. Explaining the Lachesis consensus process like other cryptocurrency networks, Fantom includes a number of capabilities like smart contracts, dApp development, and transaction settlement. The manner that its Lachesis consensus process addresses the scalability issues of existing blockchains, however, makes it special. There are three main features of Lachesis. Finality. Transaction settlements on FTM happen much faster than on most blockchains because there is no need to wait for blockchain confirmations when sending FTM to someone else. Leaderless. Lachesis is leaderless, in contrast to typical POS protocols, which frequently have fewer validators, leaders, to execute transactions. Being leaderless enhances network security since the network's fate is not decided by a small group of individuals who may make mistakes, act selfishly, or be swayed by attackers. Asynchronous Byzantine fault tolerance, aBFT, nodes can reach an honest consensus, regardless matter how many or how few of them engage in harmful behavior. Asynchrony makes sure that not every node must get to a consensus at the same time. Asynchronous Byzantine fault tolerance, aBFT, explained. Byzantine fault tolerance, BFT, which is based on the Byzantine generals problem, is improved by aBFT, as explained. The issue is that because they are spread out, various generals find it difficult to coordinate an assault on a city. Since direct communication is impossible, they have to use unsafe channels, which causes trust issues. It is possible for messages to be intercepted, or generals themselves could decide to behave dishonestly. The computer nodes of a decentralized network are represented in the example as the generals. This illustration illustrates a challenge faced by decentralized networks: how to persuade people with asymmetric knowledge to agree on a course of action. BFT, or Byzantine fault tolerance, provides a remedy. Without requiring mutual trust, it enables nodes to agree on the time and sequencing of transactions. This enables participants to reach a fair consensus even in the event that some nodes act maliciously, by choosing to postpone transactions. In other words, even if some nodes aren't performing as they should, a BFT system can still function. Traditional BFT mechanisms have a drawback in that nodes will be unable to reach an honest consensus if the proportion of malicious nodes in the network is equal to or higher than 1/3 of all nodes. A fair consensus can be obtained even if more than 1/3 of the nodes engage in malicious behavior thanks to aBFT's removal of this upper restriction. As aBFT believes that honest nodes' messages will eventually be delivered, messages may be lost or perpetually delayed. Even with fewer operational nodes, the network can still function.